So this is question 1 in exercise 18b, and what we're asked to do is find the magnitude and direction of the resultant of the forces shown below. So we have here in question 1, acting at a point here, we have the force of 75 newtons acting at 65 to the horizontal in positive direction, and then we have the force of 35 newtons acting at an angle of 24 degrees to the horizontal, acting in the negative direction, pointing towards the negative direction, and then we have 60 newtons which is acting downwards on our axis. Okay, so we're going to try and find the magnitude and direction of the resultant force of this. So what we're trying to do is put all of these forces and find just what the one horizontal and vertical force is. Okay, so we're going to look at first of all each one individually, and I'm going to start off with the 75 newtons. Okay, and I'm going to just draw another diagram over here to help us. So starting off here, I am going to do the 75 newtons with the angle of 64, and I'm going to split this into two components, and then I'll do the same for this one, and then obviously I'll mark on this one as well. So for starting off, for 75 newtons and the angle here included, so this direction here we're going to have, because remember we split this into a horizontal and a vertical component. So the horizontal one's going to be 75 cos 64. Remember, cos is when you include that angle, it's contained. Alright, and then vertically the angle's not contained, so it's going to be 75 sine of, what is it, 64. Okay, so that's that one there split into its horizontal and vertical component. Alright, I'm going to now do this one here, and I'm going to split that into its horizontal and vertical component. So we'll just do the horizontal one first, just because it's easier with the angle being contained. It's always easier to do the cosine one first, I find. So for that one there, we're going to have 35 cos 24. So 35 cos, and it is 24. Okay, and then for the vertical one there, going upwards, we're going to have the angle is not included. Okay, so it's going to be 35, and it's going to be sine 24. Okay, so what I've done there is split this into a horizontal and vertical. Now I haven't drawn a second arrow in here, you know, it may just confuse things a little bit, so I've just kept it going the upward direction. Now this here means this is going to be pointing upwards and this is going to be pointing upwards, so actually we will add those together because they'll be both pointing upwards there as well. It's just both going upwards in that direction. And then the 61 here, we will be fit to mark on 60, and it's just acting downwards because it's not, there's no angle in there. So there's all our forces, and then we're going to work these out now to try and get just a horizontal and vertical component for these. Now I know yesterday in the example in the PowerPoint, what we done was work out the value for each of these and rounded it to 2 decimal places. Now I know when looking at some of the solutions that can get a bit messy, so I think maybe it might be easier if we take the direction for the horizontal and just write it all out and then work it out, and then take the direction for the vertical, write it all out and then work it out. It'll leave less messiness and less angle or values and so on wrote up here. So what we're going to do is, now I'm going to resolve mine because I'm not working out these values now. We're not sure which one is largest. If you look at this diagram, do you think this 75 force, which is bigger than 35, is going to be stronger in this direction? Do you think it's going to be moving more in a positive direction this way? And then do you think that maybe the 60 newtons will be a stronger force going down, or is the 75 with this angle and the 35 with this angle going to be stronger going up? So it could be hard to tell from that. So what I was going to do is pick my two directions, and once I've worked out my two directions, if it ends up that it's a negative answer, that means that it's just going the other direction from what I had started with. So I'll show you what I mean. So I'm going to resolve these now, and I'm going to go to the right. So I'm just going to work out these all to the right. Okay, so what I'm going to have is 75 cosine of 64 to the right. Any other forces going to the right? No, but there's one going to the left. So I'm going to have to subtract that. So take away minus 35 cos 24. Okay, I'll work that out in a wee minute. And then that's the only ones that are going horizontally. Now for the forces that are going vertically and perpendicular to these, they have no effect on these two forces. So anything perpendicular has no effect on these, so it's only the horizontal ones we're talking about. And then we're going to do it to the vertical direction. Now we could go up, we could go down. We're not sure which has got the stronger pull because it's just maybe a bit messy if we write the values in there. So I'm just going to go to the right for resolving and up as well. And maybe if that's the direction you want to try and do each time, always just do it to the right and do it to the vertical direction and the upward direction, and then take your two answers. If they're positive, then that's the correct direction. If they're negative, then just change the arrow direction, you know, for your answer. So for this one here, what are the vertical forces acting up? So acting up, we had these two forces here. So we had 35 sine 24 plus we had this other force. So even if you didn't add them here, we're going to add them down here. 75 sine 64. So we have these two forces acting up. But what else is vertical? We also have this one acting down. So I need to take away the 60 because that's going, we're resolving it here in the upwards direction. And these two are acting up, but this is going in the opposite direction, so we must take it away. And we'll work that out now. So the first one here, when we work it out, it should be 0.9. Now it's 904 and so on, more digits. I know yesterday I said we'll round that to 2 decimal places, but because it's a 0, I'm actually going to stick an extra digit on there and do that to 3 decimal places, but normally you just would do it to 2. And on this one here, 35 sine 24 plus 75 sine 64, and take away our 60, we should get 21.65. Okay, so now we have our two values, this one here and this one here. All we have to do now is put these into a little triangle to try and find the resultant force. Now this one here has gone horizontally, so I'm going to draw my triangle and I'm going to go horizontally for that one. And what is the force in that one there? 0.904. So actually the force was pulling stronger in the right because it turned out positive. If that had come out as a negative minus 0.904, then that just means actually it was going stronger in the other direction. Okay, and if we were drawing our triangle now, we would just do our little arrow going the other way, so that would allow us to change it. And this one here, it's going upwards, 21.65. So whenever you do these arrows, we follow one arrow, the other one follows up, so they're following round in one direction, and that's going to be 21.65. Again, if this happened to have turned out as a negative minus 21.65, that means that actually the force didn't act upwards. If the stronger force acting upwards, it actually then would mean that it would have been going down the ways. So whenever I was doing my triangle, I would have done the arrow going down the way. So it just means that's all you have to do. Now we have to find the resultant force. So this force here and this force here combine. A little triangle of forces, they combine to give this force here, and we always then start, so it goes across and up, and then you go back here, and that means this is the force then that combines these two. Alright, and this is the one we want to find. So obviously this creates a right angle triangle, and we're going to find this here resultant force, and then we want to find the angle that it's acting on towards at the horizontal. So it's just going to be Pythagoras for that. So what is our R going to be? Well, our R, we're just going to use Pythagoras theorem there, so we'll have there R squared equals, and we can have there 21 point, doesn't matter which one we do, 0.65 squared plus 0.904 squared, and that would be Pythagoras theorem. And then how do we find our R? It's just going to be the square root, if you can see that okay, the square root of all of that. So 21.65 squared plus 0.904 squared. Alright, so when you do that on your calculator, you should get a value of 21.668 and so on, and then we'll round that to 3 significant figures. It's going to be 21 point, and that's going to be 7, and that's going to be the resultant force. That's going to be our newtons. Okay, so all we've done is take all the horizontal, took the vertical, we could put all these forces into horizontal and vertical, made them into the triangle. We've now found the one force that combines all these here. Okay, so if you imagine if something was pulling here in 3 directions, pulling like a ball or something here, and something was pulling at this direction at an angle, and something was pulling this direction at an angle, and something was pulling down the ways, what way is this particle going to move? And we now know it's going to move with the force of 21.7, and what is the angle that it's going to move at? That's what you're kind of trying to work out. So the last thing just is the angle, and that's just going to be from the triangle or using your trig, and it's always just better just to do your tan, the opposite over the adjacent. I know I've just worked that out, but just leave that, just always use those two, it's much handier. So for that one there, we'll have, I'll do it over here, so tan of our angle, and that's going to be 21.65 over 0.94, and we know how to work that out then. So theta is going to be tan to the -1 of those angles, just 21.65 over 0.904. If you can see, I think the light's shining on that. So just on your calculator then, we can get that angle, and that's going to be 87.608 and so on, which will round to 3 significant figures. So 87.6, and that is our angle. Okay, so what we'll write down then is just what have we got here? We've got a force. I'll just move this up and then I can move it back down for you to see after. So we have here a force of 21.7 newtons acting at 87.6 degrees above, force of 21.7 newtons acting at 87.6 degrees above, because you can see here we've worked it out, it's above the horizontal. If the triangle ended up in below, then you would say below the horizontal. But as long as you've worked out really the magnitude and direction, we know the magnitude is just the size. What size is the one force? 21.7. And what's the angle that it's acting at? It's acting at an angle of 87.6 to the horizontal there. And that's really all you're trying to do there. Okay, so if just skim over that quickly, we've got 3 forces up here. Imagine something like a particle here being pulled in 3 directions. What is the one force where this thing is going to end up going? So you're combining your 3 forces, splitting each of them into horizontal and vertical, and this is already here. If you want, just always resolve it in the horizontal going to the right and vertical going up. And if they work out positive, all in well, you can draw your little triangle. If one of them works out negative, then just change the arrow and just draw your triangle going the opposite way or going down the ways, instead of the way you'd have done it if it was positive. And then just use your Pythagoras to find your force, and then use your trig to find your angle, and then that's it all completed there. Okay.